For centuries, cleaning relied on a simple chemical reaction, base-catalyzed ester hydrolysis. Boiling animal fats or vegetable oils with an alkali produced a natural soap, a basic mixture of sodium salts and fatty acids. The conjugate acids in these natural soaps are inherently weak. When introduced to synthetic fabrics and varying water conditions, they struggled to break down persistent oils and frequently left behind dulling mineral deposits on clothing. By the mid-20th century, the limits of natural soap forced a pivot. Consumers walking down the aisle saw boxes of ivory soap flakes sharing shelf space with a new class of synthetic detergents like Tide and Shear. Replacing soap on a national scale required enormous manufacturing infrastructure. Facilities like this early Procter & Gamble industrial complex were built specifically to handle the complex synthesis required to mass-produce these highly concentrated chemical formulas. Washing clothes had outgrown natural processes. It now relied on aggressive, precisely engineered chemical systems. This diagram maps the global web of parent companies that manage the hundreds of cleaning brands filling a modern laundry aisle. A closer look reveals massive central entities, specifically Procter & Gamble and Nestle, control the vast majority of this manufacturing infrastructure. To supply that network, production moved into hyper-automated megafactories. The manual mixing of the past has been replaced by clinical environments featuring miles of mirror-polished piping and high-speed spinning decanters. These environments operate under absolute tolerances. Every stage of production demands total control over ambient humidity, liquid viscosity, and the chemical stability of the raw materials. The modern detergent plant operates as a high-tech armory, synthesizing microscopic molecular weapons for distribution around the globe. The primary functional component synthesized inside these facilities is the surfactant. This is the active ingredient that physically strips oil and dirt away from fabric. This structure represents sodium alkyl benzene sulfonate, a standard synthetic surfactant used in commercial detergents. The molecule has a dual nature. One end features a hydrophilic head that bonds with water, while the hydrophilic tail attaches to oil. When surrounding dirt, they form a micelle. Tails point inward, trapping oil. Heads point outward, washing away. This microscopic mechanical action is the core engine driving every liquid and powder formula. But surfactants face an immediate environmental obstacle: hard water. When tap water contains high concentrations of dissolved calcium and magnesium ions, those metals react with the surfactants and neutralize their cleaning ability. This formulation chart highlights the chemical countermeasure. Notice the ingredients labeled builder, such as sodium tripolyphosphate, which are added specifically to disarm those interfering ions. These builders act as water softeners through a process called chelation. They hunt down dissolved metal ions and pull them out of circulation. This diagram shows the mechanics of chelation in action. The tripolyphosphate molecule physically traps the target metal ion, labeled here as M, holding it securely within its structure. By clearing the water of dissolved metals, builders establish a defensive perimeter, ensuring the surfactants remain fully active to complete their primary task. Delivering these precise chemical ratios directly into a washing machine led to the most complex engineering challenge in the household care sector: the modern multi-chamber detergent pod. The difficulty lies in strict isolation. The pod must house highly concentrated competing chemicals like surfactants, builders, and bleaches, keeping them entirely separated within a single, fragile, water-soluble unit. Achieving this requires automated, high-speed injection. Industrial nozzles fire exact microdoses of vibrant liquid into distinct chambers, made of a thin, dissolvable film. The sealing phase immediately follows, locking a moisture-proof lid over the chambers. This creates a hermetic barrier that protects the reactive chemistry from outside humidity until the exact moment it enters the wash water. The finished units then cascade into durable, child-resistant tubs, sorted and packed at a speed far beyond human capability. Every load of laundry depends on this exact sequence, a completely automated, planetary-scale infrastructure designed entirely to execute microscopic chemical warfare on a single stain.